while ago, we did a video titled "Power Conditioners May Actually Make Your Audio Worse," and that received.
That looked like somebody else I knew.
Oh,
Okay, it got some comments,
Yeah.
and a lot of those were valid. We vaguely addressed some of them, but I understand the confusion. So we figured we would provide clarification what we mean by that, because this is actually a pretty popular topic. A lot of people run power conditioners. A lot of people have power issues, and a lot of people think it doesn't make a difference.
So there were some comments that we wanted to kind of address. And I mean, also, I think there's a general misconception, a few misconceptions that we can touch upon about what power conditioners, there's really three kind of, I'd break this down into three categories, I guess. Well, a power conditioner is a passive device. It can't generate power, right? It can't supply power. If you have a low voltage condition, you're screwed. It's not made to tame that. It's designed to eliminate pretty much noise riding on a signal. Okay,
So some might
passive.
have multiple output taps on a transformer and be able to boost voltage.
They do make that, these
Yes.
AVRs and stuff, but you don't
I
see
got
that.
one.
You don't see that too often.
Yeah. That what is that?
Yeah,
that
but
guy?
that's not variable. It just
No.
always boosts
Always
voltage.
boost it. Yeah.
Well, what the
So
hell
it's
good
not
is that?
really.
Just
It's just assuming you always have low input voltage.
Yeah. Again, these things aren't really common to see. Normally, they don't generate power. They're passive. So
Generally.
that's the easiest way to understand it without
Right.
getting into every possible world condition that we could create here with a conditioner.
Well, yeah, mine is super passive. Yeah, because it's just on.
Yeah, it's like a transformer, some components to filter and mitigate noise and whatnot.
Yeah, and then you've got your UPSs, which are readily available. People use them on computers everywhere.
Right.
They're made to come on when the power goes out.
Well, actually, I think this is a point of reasonable. I think this is a point that's reasonable to clarify, because for some reason, a lot of people think that a UPS works like magic. You plug it in, and new power comes out the end.
Oh, right.
And you can get units that actively regenerate, typically called online or continuous.
Well, that was the
UPSs.
third one I was going to get into.
Double
would be
conversion.
Something that's always running continuously. And it's a
Right.
power regenerator, which would be the third thing to look at. Something like PS Audio makes them.
Right.
So,
But usually UPSs don't do this. The vast majority are typically called line interactive.
yeah.
And all they really do is maybe they boost or buck the voltage to try to accommodate
They might
voltage
be able
swings.
to adjust for fluctuations.
But they're only on when the power goes out. And even then, even if they are full sine wave, there's huge levels of variation to what they call full sine wave. Something that's made to like power an electronic device or switch mode power supply for your desktop PC. They don't have the same THD requirements.
It's a sloppy sine wave.
They're very sloppy.
Yeah.
And they tend to have a lot of issues around the 0 point, which may or may not cause noise in your system, which we talked about in the previous video.
Yeah, and also I don't even trust using like a few $100 UPS on sensitive electronics. Like
Some of them
high-end
even
stuff.
say don't use it on sensitive electronics right on them.
I don't think it's a good idea.
The vast majority, even if they say sine wave, are very poor output power quality. The power you get from the wall is probably better. And the biggest issue is they usually are relatively high resistance.
Which is something else we have to talk about too. Is that what is the problem coming out of the wall that you're trying to solve?
Right.
That's how you decide which one of these three you choose. What's the problem? And that's where I think I see a lot of mistakes made. People just do assume, if I put a UPS, I'm good. And they're not, or I'll put a line conditioner in to solve this problem, but they're not really addressing the real issue, which some states have brownout conditions. They're running 85, 90 volts. Conditioners can't help you there. So, but people think they can. So that's where we need to kind of get into the nitty gritty here and just explain that there's a purpose for each one of these devices. And you got to know what the reason is you're getting it for before you go and buy it.
Yeah, I guess your baseline reason is I need power to run things. It doesn't need to sound good or anything. You're just running a refrigerator or something,
Yeah.
So it just needs to work.
Yeah, which is like a generator.
Yeah, generator.
Or, something like that. Yeah, where, some people have some people are baller and they have whole house generators that come on when the power goes out. And I don't even know what's the sine quality on that, the wave quality out of those. They're actually generators, right?
It depends on the generator head itself. Typically, it's poor.
Yeah.
That's what I would usually expect. And I have a Honda EU7000IS, and it's a sine wave output inverter.
It has got an inverter, yeah.
It's pretty good.
Do you know what they rate? Do they rate the distortion?
They do. I think it's less than 5%.
Yeah, which
I'm not
isn't-
sure. It's not
which isn't crazy.
super high, but it's not super low.
Right.
They're designed to, they do actually specifically claim you could run sensitive electronics, and you can. They're very good at maintaining frequency and pretty good at voltage.
Yeah.
The THD is okay, and it doesn't get that bad even with high loads.
But that's a high-end, so to speak, high-end generator
Yes.
because it's got an inverter, which is electronics, that are actually that are producing the sine wave.
The biggest
You know?
issue is the typical whole home generators you see. Usually, the generator head causes huge distortion as the load increases.
Oh,
They're not really able to maintain a sinusoidal output. So the THD could be very, very high at high load. And they might be rated commonly at like 20 kilowatts, but really they're not capable of delivering more than maybe 2 to 5 without very high THD, which your refrigerator won't care about. Your electronics probably won't really care. THD for the most
or the
part
HVAC,
isn't
or
that
the
big of a
AC.
deal. Yeah, a motor or
Yeah,
the
right.
blower
Sump pump.
motor and your sump
Right.
pump.
Yeah, the things that you really
They don't
need
really
to worry
care
about.
that much. So 5 or 10% THD isn't a big deal. And in a lot of these generators, you could expect to see 20 or higher percent.
Yeah, I could see there being a problem right there. Like, let's say something kicks in like an AC unit or something, and you actually have a generator capable of running that.
Right.
You could get some weird spikes or something going on.
That's a really big issue.
you know.
yeah.
So you got to watch what you're running when you're running on generator.
Yeah, I'm
You know?
assuming it probably matters how much it's loaded down too.
Yeah.
Like how much it's actually working.
to begin with.
Yeah.
Yeah.
Well, the
But it's a
biggest
sudden change that would
Yeah.
be an issue.
Yeah.
Right.
Sudden change in
the
load.
biggest issue you seem to have typically on those is if you have a generator that's not particularly high capacity and it has very light load on it, and then a significant load shows up.
Right.
So your house just comes on the generator.
Kind of flips it out.
You have a 500 watt, 1,000 watt load on it, so it's the generator is basically idling, and then you have a AC kick on that hasn't been on for a while, and then it sees a momentary 10 kilowatt plus peak load. So the generator goes from almost no load to very high load.
Or even stall, really.
And in a lot of situations, you'll get a big bog, huge voltage drop, huge noise.
Yeah.
You could get pops and stuff like that out of more sensitive electronics. If you have like an audio amplifier, I've heard things like that in the past. It seems to be common enough. If you have a huge change.
Yeah, so bottom line,
in
if
the
you're running
generator.
on generator in a home, you probably should just keep your audio gear turned off.
It's tricky to
you
run
know,
on a generator.
or unplugged until whatever caused the lack of AC to go away, you know. And that's assuming you don't have like really fancy Bauer filtration or something that's protecting the system from these things from occurring on a generated line, you know.
Well, I guess nowadays you can run like a power wall. I don't know what that sounds like, but then
Yeah, do they rate the distortion?
They do. I'm not sure what it is, 5% or something,
for that.
3%.
So it's nominal.
It's okay.
Yeah, but still noisy.
Yeah.
So
Probably
that-
noisier than out the
That's
wall.
where we get into number 3, where I was going to suggest something like PS Audio makes the power plants, and they're actually regenerating power. You can also get a full online, what do they call them, full online UPSs? Sign?
Yeah, online or double conversion.
Dual conversion, right? Yeah. Where they're always running. They're always generating power. Again, so you're isolating the line somewhat, the line coming in from the home from the gear.
Yep. And there's a really big difference in quality UPSs.
And they're also
Really
the price
big.
is tenfold
Huge difference.
versus your normal UPS you get for your computer or something.
Right. If you look at the retail price points, you could get 1,000, 2,000 kVA, or 2,000 watt or VA UPS for a few $100 if it's just a line or interactive unit. And even if you step it up,
that just comes on when the power
only
goes
comes
out.
on when the power goes out,
Yeah.
and they have no thermal solution that's really sized for brief run. So they're only really made to run 5 or 10 minutes.
Until the battery dies. Yeah.
Right. And even if you say change the battery to a bigger one, typically they would have thermal issues. They're not designed to run long term, which you could kind of sort of resolve that, but they're really poor design to run long term. What you really want, if you want to actually provide protection to your electronics rather than just power in a power outage, is a double conversion or an online UPS. And those are way more
Yeah, they're
expensive.
thousands of dollars
They're
depending
looking
on the
at
size.
least 600 to 800 or so in the entry level, but the big ones, a few thousand.
Yeah.
And you can get very good ones. They're pretty good.
And
But-
I think you do want to get a name brand when you get to that level.
Yeah.
If you're seriously looking for protection, you're actually, now let's talk about that. We missed that. What are we protecting from? Right? We're looking at, I think, to get something like that where you're continuously regenerating power, right? In the high end of things like PS Audio, they're obviously saying, well, you lower noise floor, quieter, for the electronics. It makes sense. Makes sense all
Yeah.
around. But if you're actually looking to purchase something like that because you have power issues, that's kind of a whole different ball game. You got to look at what issues you're having. Brownouts, low voltage all the time, for how long? Is power going out where you need a battery solution too? So that's where you get into the upper end of things. And do you need to listen to your audio while all this is occurring?
Yeah.
Right.
Or can you just turn it off, walk away, and worry about come back when it's over?
Or you go portable.
Yeah, well, that's true. Yeah, run the battery.
powered.
Yeah, full battery.
I guess I see no issue with running your system on a online UPS, double conversion online UPS. Generally, they're pretty good quality. They're made to run continuously. They usually have decent outputs. It may not be better than what you get out of the wall. Depends on your area. But you'll have consistent power. So if you have gear that's for some reason frequency or voltage sensitive, you can control your output voltage with those. You actually could control it depending on the unit, you could make it 110, 100, 120, 127 volts commonly.
Yeah.
And so if you have 92 volts coming into your house all the time, or 102 or something low, and you want to boost it up because your gear works better on that, or it's made for 120, you could do that with a online UPS. So that's one thing right there that's resolved. Now, the big issue with those is they may not have the same output impedance as you would get from something that's purpose-built for the task.
Yeah, I like the PS Audio.
Like something like the PS Audio
Yeah.
Regenerator.
So if you're looking for running like amplification with it, or an amplifier
Right.
wants to see a low impedance source, it's drawing power at an audible rate. Basically, people argue with it's a power supply rate. It's all bullshit in the end because it's reacting to the load that it's providing power to, and that reaction that it has flows back through its power supply, through the power cord, through the source. No way around it. You put more out, you got to put more in, okay? It may not be at an audible rate, but it is an audible rate because it's happening 160 or 120 times a second. So technically it is an audible rate.
It depends on the design. But for the most part, lower output impedance to the power is better.
But you're looking at, in the case of an amplifier, you're more or less, because you're charging filter caps, the bigger the amp, you're basically drawing power near the peak of each sine wave. So it draws it more in a spike pattern, trying to replenish the supply when the amp's under load, right? It's more of a spike pattern. So you've got this weird current draw demand where if you had so now you look at the source of power you're plugged into. Right, let's say it's a typical UPS versus the PS Audio or just the wall. That line impedance or the limitations of the power source now become an issue because your amplifier is trying to draw in very high current spikes. And if it can't get it, you're obviously going to change the sound. It's going to change the way it sounds. Therefore, the impedance matters of the source, or how well the source can provide power.
It can.
you
And I guess the big downside is normally with the grid, you never have this issue. With the grid, the only thing that really matters is your neighbors, how much of a load they're drawing, how hot the lines are, how hot the transformers are, how far away you are from generation. But the actual generation, compared to your load, compared to your amplifier, it's perfect. I mean, if you throw 5,000 watts on the grid, it won't notice.
Right.
It means nothing.
Right.
But if you have a UPS and 1,000 watts comes on, it's a big deal.
Yeah,
it struggles to keep
It's
up.
suddenly trying to compensate.
Even
for
if you
that.
have a big one, even if you get a 3 kVA UPS, they're designed to tolerate that, but you're going to see some degree of a voltage dip under those loads. And if they're happening very frequently, if it's happening at very high frequency, then you're going to get, compared to the wall, you may get worse power quality.
Did you ever try to run a sump pump or something on a generator or a line conditioner? Or
Yeah.
a UPS?
Yeah.
Yeah. I have too. It didn't work.
Yeah, no, they go
It doesn't. The motor
Yeah,
won't
no,
start.
yeah.
It can't
It just
get
sits there.
going. And it's funny because the thing's rated for you thinking, 1,500 watt UPS should no problem. The sump should start up. Can't. The motor won't start. Yeah.
The better ones will. They'll have the ability to deliver well beyond their ratings for momentary periods. But really, if you want an online UPS, for an audio system, I probably would shoot for something like an Eaton 9PX. That's probably the way to go.
Yeah. The Eaton stuff is
Those are
professional
very
gear.
good.
Yeah.
But if you get like a no-name brand, some of them are really frumpy and they do not meet their specifications.
Yeah, right. The way I see it, there's a couple scenarios that you're looking to try to solve. One is you just want a quiet signal. You're not aware of any issues, right? You're not aware of having brownouts. You don't have constant power failures. Your home wiring is more modern. Life is good, but you're cautious. You're looking for an insurance policy.
Right.
that's where line conditioners work out. Just a basic passive line conditioner. And if you're looking for audio quality, then you got to look at some of the big boys in the audio business that specifically design these things for audio gear.
Right.
And they're tailoring the filtration because you can over filter too. You could put a typical whatever commercial filter in there and actually it trashes the sound. It goes the wrong way. I've heard that happen. It's an over filtering. It's possible. So you're just for whatever reason you're doing something. You're adding too many passive components probably in series with the power, and you're not realizing how it's affecting.
Well, it probably just increases the output impedance.
Well, exactly. Yeah. So you get enough chokes.
It's not
in
going
line.
to decrease it.
Yeah, it's not made. It's not made for that. It's made to decrease noise, but it isn't necessarily made to listen to. It's kind of like putting a shitty power cord in something. If you ever heard a shitty power cord versus a real one, but that's a whole different topic.
But generally speaking, I don't see any reason why anyone should run their equipment on a conventional UPS. That's even if it's sine wave, unless it's a dual conversion or an online.
Agreed.
Very little benefit. I think it's probably a worse idea.
Yeah, I don't trust standard UPSs for audio gear. Yeah.
Well, unless you just for some reason had to listen to music
In the power outage, yeah.
Yeah.
Or maybe if you take one of those and then put a line conditioner after it and then plug your gear into that, maybe you'll filter out some of that distortion. More likely, you'll blow up the conditioner.
If you have very good power quality, though, a conditioner might work, might actually help. But you need excellent power quality coming in, and then it's possible it'll make it a little bit better.
Well, again, and now the question is what's quality?
Right.
See, reality of it is there's no good way to explain that unless you have an oscilloscope or something
You
to
need to
actually
look at it, yeah.
look at the damn power. Otherwise, you got to know what you're dealing with. Are you flat topping the sine wave where you've got a lot of harmonics happening? There's no, they used to have back in the day, they used to have, in the professional world, you would have somebody come in and take a look at it. They would bring a scope, and if you have intermittent issues, they would actually have line monitors that they leave, that recording line monitors. Remember we used to deal with that years ago?
Yeah, you got one.
Yeah. You plug it in the wall, give it a day or two, and it records all events on the line. Anything that's abnormal, it records, tells you what voltage it peaks at, how long the event occurred, when it occurred, to pick out an issue. Like sometimes you have something going on in a house that's causing this. And
Yeah,
really,
it could be equipment in your house turning on or off or something.
or a faulty motor on something like an HVAC or something where
Sure.
it's generating noise, and knowing when it happens is part of figuring out what it is in the house that's doing it, or maybe you got a guy next door with this construction going on and they got saws going all day long, and those are issues. Those will come back to bite you. I've actually ruined a piece of gear with contractors working in my garage cutting with a saw. It ruined one of my pieces of gear just by having a
blew it up
circular
or
saw.
something?
It just failed. I don't know what happened, but yeah, it failed, and it was somewhere else in the house. I don't know whether it was on the same circuit, but it was probably on the same phase. They plugged into the garage, and they're running probably some saw that's been, got 1,000 cutting hours on it. The motor's probably, it's probably brushes or something. I don't know, but bottom line, right? You think about that, and you're throwing all that hash into your home, and if there's nothing there to protect it, bam, bam. So, I guess that's somewhere where line conditioners can help a bit too, because they can help filter some of that out, but they won't help you with voltage anomalies and stuff like that.
Yeah.
So now you jump into the UPS, and we recommend with audio electronics, to not use a cheap UPS. You need, like you said, dual conversion.
Yep.
Full online all the time. Something that's always regenerating power. It's a power regenerator.
You can get them inexpensively sometimes, but they're very expensive now.
Yeah.
And so really the next level beyond that, if you want to just be sure, a audio type design power regenerator, like something like PS Audio makes, those are good, but they're expensive and you may not need it. So it really depends on you, I suppose.
But if you're shooting for
depends on
audio
what you're looking
quality and you have issues like that, I guess that's kind of your only solution.
Well, yeah.
Yeah.
Speaking of saws, though, I have been using a saw once, and then you could hear the saw through your computer speakers.
Oh, yeah.
That's concerning.
Yeah.
So
Well, that noise gets everywhere.
Yeah, it's bad.
That's some nasty stuff when you talk about, especially the old brush style motors that are using some of these tools.
All the corded stuff for the most part is brushed.
Yeah.
All the power tools.
Those are noisy, and as they get older, they just get more noisy.
They tend to get very
until they
noisy.
fail,
Right.
until they stop working.
Yep.
Do you see sparks flying out the motor, the back of the motor?
Right.
That's pretty much the game over for the brushes. But can you imagine what that's wreaking havoc with everywhere they're plugging into it? Everywhere they plug it in? Oh, my God.
Well, most people don't have a whole lot of high-end audio gear plugged into the same circuit. that
Probably
this
not.
Well, those
corded
that,
saws
those that
plugged
do, what would you do in that case? I mean, these guys tell them to bring their own generator. I guess don't
Yeah,
even plug
they do
into my
use
house.
generators,
I don't
yeah.
want you plugging that saw into my house.
Well, for the most part,
You know?
people are moving to cordless now, anyways.
That's
yeah,
true.
pretty much.
Yeah,
Yeah.
actually, problem solved.
Or
yeah.
you have a dedicated home run. This is the saw outlet. It's just like
yeah, at least.
They put one of those in here when they were doing construction.
Yeah,
They put a separate circuit in for them.
did they?
They did.
They're smart. Well, I know, remember we used to run our old CNC machine. The
Oh,
Mazak
yeah.
was brutal on the power.
Yeah.
It was throwing stuff all over the
oh
building.
yeah, because it had to slow down.
We're worse than on the computers.
We
It
needed
was
to put a filter on
everywhere.
it.
Yeah.
Everywhere in the building, you could hear every time the spindle
Yeah.
started and stopped.
Yeah, that was a big filter.
It was like 30 horsepower, wasn't it?
Yeah, what the
Yeah.
hell is that filter rated for? I don't even know. I forget.
50 kVA.
Yeah, 50,000.
Yeah. Yeah. Well, yeah.
Big chokes, right?
yeah.
Mostly big chokes,
It's
and
a big unit.
some
yeah.
caps, and it was like a multi-pie filter arrangement or something for 3-phase 208.
Well, we started
You know?
losing electronics.
Yeah,
So
right.
like, the monitor failed, and then a computer failed. So it's like
Yeah.
we need to do something about this.
And we kind of blame the fact that we thought the pole pigs were too kind
They
of
were.
smaller.
They were 10 kVA.
Yeah, and the line coming in was small too, coming into the building because that building was never designed for that. Our old building.
Yeah.
Yeah, our old building.
But that's actually common. The power company, they oftentimes run their transformers pretty hard because they know, especially in residential, they're not going to use anywhere near the power that that they claim they're going to.
At least
Usually,
not continuously.
right. Usually, you'll
yeah. submit
submit a load chart. You'll tell them what you expect to have on in the house, how much power it takes and stuff, and they'll throw it through their equation or whatever number that they have.
I think it was when we
But-
built this building 5 years ago or so they were throwing 1.7 at me. Now whatever the KVA rating is of the pole pigs, multiply that by 1.7 is what they'll allow for a load chart,
Right.
assuming you'll never turn everything on in the building
Well, then they also
at the
usually
same time.
they have some sort of number they multiply your anticipated load by to assume how much power you're actually going to draw. Because
Right.
obviously you tell them, well, I'm going to have this and that, and I could draw maybe 20 kilowatts. They'll say, all right, well, you're probably only going to draw 4, really.
Right. Right.
And then we'll size a transformer for that.
Yeah,
And
they
they'll
even.
put a
I
10
think they even
kVA
said
in.
verbally, "Oh, we'll even consider double being okay."
Yeah.
But 1.7 is kind of their number. Which is a funny number because 1.717 is peak times RMS. Peak is your RMS, right? So if you ask me, they almost came up with that number out of the blue somewhere.
It's arbitrary, probably.
Yeah, really.
Well, they probably just go with that, and then if they have a problem, then we're like, we'll work on it, replace it
Like,
later.
if the pole pigs start
Yeah.
smoking,
Melting.
yeah,
I don't think they fuse them, but maybe they have a thermal overload in them.
they must have something because it'll take the whole line down if it failed. Because at some point, I think when they fail, they short, don't they? I don't know. It's a transformer.
I don't know.
Yeah.
I don't know. I've got
If
a
they
lot.
fail because they melt,
You
yeah,
got
they
like
short.
30 to 50 kVA coming in, and it's dropping it down to 120, 240.
You ever see one fail?
Actually, that's right. I was across the street. I was across the street, and there was a line coming across the street on the other side of the street. A line coming across going to a pole pig, and they were building the building or doing something. And I'm guessing that somehow the secondary pole got shorted coming out the pole pig. I don't know how. I don't know if someone dropped some heavy equipment in the parking lot, but something got across the pole pig, and you hear it. And I watched, and the line that was coming across the street
just
got
heating
red
up.
hot, melted, and then fell down. It's like, whoa, that's a hell of a fuse.
It's a
man.
hell of a fuse.
The supply line, the high voltage line
Right.
coming over to the pole pig melted.
Yeah, that works.
So I don't know what happened in the pole pig. I don't know. Maybe they're not fused, but
I don't think they are.
it took out the line. That was the fuse. The line was the fuse.
Eric has a video of it happening actually down his street.
Yeah.
He didn't see it, but you can see a blue flash in from his security cameras, and the power go. You see everything
Yeah,
go
it's funny.
black.
You saw a
pretty
blue
sick.
flash and all the lights flickered around the houses.
There's probably YouTube videos on that.
Oh
too.
yeah.
Yeah,
Oh,
maybe we'll find one. We'll
There's a
post
lot.
It. We'll
Yeah,
post
there's
it in the link down
It's
below.
pretty serious. But
Yeah. Yeah. It's not something you want to be near when it happens.
Yeah, I was like
Anyways,
a parking lot away from one going off one time, and it was like, oh my god.
Yeah.
People just,
It's bad.
Yeah.
The moral of the story is sometimes the power company does funny things and they put your house on a very undersized transformer for what you as an audiophile would do. Right? Obviously it works. It's not burning down, so it makes sense. It's cheaper for them.
Yeah, they didn't plan the electrical grid for you to listen to music with.
No. So sometimes there is an advantage to like a regenerator that's optimized to deliver high current quickly to minimize the output resistance. But for the most part, I think people misunderstand what the filtration can do, and certainly misunderstand what a UPS is.
You know, what the capabilities are of these things.
Right.
Yeah. Which are minimal, really.
Usually.
Relative to having to regenerate power.
Mhm.
That's the way to go. In IMO, that's the way to go.
Or double conversion UPS.
Dual conversion UPS, you got to be regenerating it. It's got to
Right.
be on all the time.
Yeah, those are different animals
Because that way, whatever happens coming out the wall ain't happening at the other end for the most part.
for the most part.
Yeah, we can't really exclude like a
Well,
direct
things could
direct
still
lightning
fail.
hit on the
Yeah.
pole outside or anything like that.
Well, they are designed to
you're-
isolate.
You're shit out of
in those
luck at that
cases.
point. Yeah, but a lightning hits, you're shit out of luck.
Well,
Hmm.
Anywhere
depends on the
within a
design.
mile of your home and you got above ground wiring, you are pretty screwed. It's probably going to get in there. You know, that's the beauty of having underground wiring going into homes too.
It's a little better.
Safety.
Yeah, if a lightning hit occurs, at least it's far enough away where it probably won't reach you.
Well, and
Yeah.
people can't hit poles with
Well,
your
that's
power
true
on it,
too.
So,
Yeah,
it helps.
It solves a lot of problems.
Does solve problems.
I can't figure out why they talk about improving on the grid in the U.S. That should be something that we should shoot for. Everything should go
It
underground.
must just be too expensive.
It's got to be ridiculously
Yeah.
expensive.
Because on all the big areas, you still see poles.
Well, can you imagine
The main
pumping
streets,
high voltage
always
wiring
poles.
in the ground throughout the country?
It's got to be
All
expensive.
the obstacles you'd be running into.
Right.
The shit in the ground you don't even know about that you'd
That's
be
not
running into.
supposed to be there.
Yeah, I can't even imagine going down one street, much less the whole country.
They're actually doing it right now here.
How about above ground pipeline? Can't they just run the damn wiring just on the ground in a pipe? They do that
Well,
for
it's not
gas.
insulated.
Right.
Well, you could put insulation in it.
Yeah, I don't know if that would be cheaper than putting it on a pole.
I don't know either.
Mm.
You still got to have right of ways and everything like that, and you got to.
Yeah.
Now, how do you get through that? You can't cross. You can't
That's the
drive
problem,
over
yeah.
this. Yeah,
Well,
it's
I
a real-
mean-
it's a real issue, isn't it? We got
a
it.
problem.
Was it Tesla that came out with wireless power transfer? Was he the one working on
Yeah.
it?
Well, he was
Well,
doing it.
Was it Tesla?
Yeah,
Yeah.
it wasn't exactly finished.
He was like frying the cities. The lights went out when he was trying to send power wirelessly. Right?
Yeah.
I thought he succeeded to a part.
I don't think the efficiency was very good.
Well, I don't think
Yeah.
it's very good. It can't be.
Yeah.
Yeah.
If you have enough power, yeah, you could send somewhere else.
That-
Yeah,
therein
people are
lies the
still
issue.
working on it.
Yeah.
It's not there though.
Yeah.
There's a lot of
It is.
Kickstarters for things like this, but they're very misleading.
Yeah.
Yeah.
They work, but it's not very efficient.
Yeah. They're gonna.
I think we're at an hour.
Yeah.
Douglas is gonna have to edit the shit out of this video. On that note, we gotta go, guys. Email us or something if you have any specific questions on this one. Thumbs us up if you like this video, and peace.